Okay, audio check. 1, 2, 3. Okay, sounds good. I think we're live. I think we're good. And I did not set up my environment at all for today's work. So while people trickle in, we're going to bring up a new Emacs. And we're going to open up our journal. And our to-do list. Let's get set up for the day. So 18th. Woof. Okay. Oh, here we are. What's going on here? Whoa. Little just warming up here today. Ooh. I was off to a late start. It was so cold this morning. I did not want to go on my run, so I had to wait for the sun to come up, and I live down inside of a valley, so the sun doesn't come up until actually quite late. And I got off on my run late, and then breakfast is late, and then the shower is late. And so a little late today. Still haven't settled into the routine yet, but we got time. It's a Friday, so it's compiler's day, so we're still on the tokenizer. We're going to be the tokenizer for a while. This whole once a week thing is not the most efficient way to generate code, but this is a nice break from main project. I think everybody should have 2 projects, maybe 3. You have your main project that you're trying to actually get done, and then you have like some hobby ones or some prototyping ones or whatever. Now, for this tokenizer generator, I've built multiple prototypes over the years for different reasons. So we're past the prototype phase. We're trying to build something a little bit nicer, but it's not a high priority, like time crunch task for me. Let's snag those 3. I don't think we are generate code for anchors. This thing and this thing for start of the line and end of line, basically. And test anchors. We also want to do some extra testing for escaped characters. Not sure anchors are proper. Anchor characters are properly supported in pattern 2NFA. Okay, so that's a pretty good list for the day. Some of these may go faster than we expect and not be that bad. But overall, this isn't that bad, really. So last time we were looking into some regex pattern issues, and it basically came down to the any operator not functioning correctly. Now, it does correctly build the NFA and the DFA for NA, but I don't like the output. Which is what reminded me to test escaped characters. So we're going to do that. We're going to make the printable text for any better. Then, last time we refactored toString and called it, basically printed a separate line of code called printable and printable length. So we're going to rename those this week. We removed the old ones. We just didn't get around to the rename factor part, the rename part. I wanted something searchable and not similar to the previous one, so I wouldn't get confused. So we'll refactor those today. So those are a couple of good warm-up tasks. This is where we want to go, though. Since the NFA, DFA is now generating correctly for the any operator, we need to do a little bit of code generation. I'll go ahead and show you what that looks like. In our VB test parser, we have the case of, well, we don't. Why not? Where is it? Well, if we try to compile this, it'll tell me where it is. Hey, JTL. Good afternoon. How are you doing? There it is. It's this one. This line needs to be fixed. So that's that task. In the old journal. And then we're not doing anything with these operators yet, so. So yeah, basically we're going to finish up regular expression code generation today for our usual use cases. Then we'll see where we go from there. I really want the regular expression stuff to work before we go back to the more tokenizer side of things. I mean, we're going to use the tokenizer basically as a testing tool of our Regex engine. So, working on Python today. Okay. Cool. Okay. So what are you doing with your Python? I got the kids in bed and everything, went on to the federal website to request an EIN, a tax number basically. And their webpage happily told me that it was outside of business hours. This webpage will not work outside of business hours. Operating hours, I guess they said. Told me what the operating hours were. It's kind of surreal in 2024. A web page that only works during specific hours. Ugh. Okay. So in main, log table, log tree, if we use the flag, so if I go to make file, are we running those flags right now in our standard test setup? Oh, That's if we run the regex pattern. That's right. That's right. Okay, so we can run that thing. And just see what we've got. Finite element program using validate calculations for upcoming software. It has a Python interface I'm learning. Okay. Yes. FEA programs are big and complicated. Oops, I reread that. Okay. So the any operator, what? Okay. Let's see here is, oh, right here. Operation any, value, whatever. Doesn't matter. So this is fine, that doesn't matter, but the DFA, I believe, has an exclusion, which is empty. There it is. There's the any. And I'm even kind of okay with that. But we don't have to be okay with that. Let's make it better. So that's in DFA state. Now, in some regular expression engines, the any operator matches anything except for new line characters, which I don't like. I want it to match anything. We can 100% make it behave like other regular expression engines, but if I say any, I mean any. I think it makes sense to me. Okay, so what we're interested in now is in DFA state. The transition. This one. Okay, so I basically have an optional rule ID, token ID. So there's not really a great way to do this. Yeah, we're just going to end up duplicating code. Copy. We're going to say if operation equals DFA state operation exclusion and either the transition inclusion is null or inclusion dot do I have like a length or count or is empty? Or is empty. We're going to do one thing, otherwise we do something else. Anything we do differently? So we just say any. We don't even need the temp string then, do we? Or any. What do you think? It's gonna work the first time out of the bag? What's up? What does your compiler target? My target is undetermined yet. We are so early in the process. This is my palette cleanser on a Friday. So the part we're working on is the Tokenizer Generator, which will generate the tokenizer, which we will then feed into a parser, which is generated by the parser generator we're going to make. And since I'm going to work on this once a week, like progress isn't that fast, I'm going to make my own language after that. I've got a name for it, and I know some of the things I want in it, but not everything. Like, this is more of an exploration. And then once we have the language through the semantic analysis portion, as far as code generation goes, I kind of want to play with all of them. Like, that's kind of a theme in this project, is I want to try everything. So, for example, every time I have an idea in the tokenizer, I have different pound defines in the code. So I say I want to use an actual iterator versus I want to walk through the structure myself for text. I want to open the files different ways. I want to dispatch my DFA states differently. Anywhere I think that there's a performance difference or a different way to tackle a problem, I'm doing all of it. So like, go to like test parts. Do you see all these pound defines in here? Do I want to use macros for my helper functions, or do I want actual functions? Do I want a big switch statement? Not that one. Not that one. It's one of these. Here we are. Where's my switch statement? Switch. There we go. Do I want to dispatch DFA states using switches or as an array lookup? Or do I want to just maintain a function pointer myself? We're going to do actual go-tos. So as far as backends go, I think maybe like first pass, early stages, we may transpile to C just so people can see it in action. Maybe we implement a small interpreter just so people can like start to see the differences. Ultimately, we'll target some virtual machine. I don't want to do LLVM. I think it's too big of a lift. It adds too much dependencies. So maybe we'll target like NASM or FASM or WASM. So what is that? The fast assembly, Windows assembly. I forget what NASM is. And if we get through that and we're happy, maybe we actually end up generating a PE Windows executable file from scratch, Intel x86-64 assembly binary packed by ourselves personally, not run through a linker at all. Something like that. But that's, years and years out. So Monday through Thursday, we develop a game. That one I'm more focused on saying, here's my scope. Let's keep it narrow. Let's not wander outside the scope too much. But for this one, this is me playing. So what am I targeting? I don't know. Everything. Whatever I feel like. And again, this is not necessarily the right way to do it. Like writing a tokenizer generator is not necessary. Writing a tokenizer is not hard. It's a loop through all the characters, and each character, as you hit it, becomes tells you what state to go to next. It's completely unnecessary. It's just for me to have fun and unwind from the grind. Making bacon at the moment, so if I disappear, it's because I burnt it. Don't burn the bacon. Bacon is too good to burn. But yes, so Nilan Dude, welcome to the chat. Welcome to the stream. Hopefully I answered your question, gave you some context. So what we're going to do is we're going to compile with the regex pattern and see. Uh-oh. What's in my transition here? The transition has occlusion set. Okay, so it doesn't have an equals. Okay. I got confused. I thought we had a pointer. We do not have a pointer. Even easier. Now see what the DFA says. Oh, look at that. It says any. So now it's clear what's going on. Good. All right, last thing. The NFA and DFA are going to output some code for me. Yeah, Pat, if your choice is between watching the stream and watching your bacon, watch the bacon. Like that stuff is too good and too expensive these days to waste. Gotta love the bacon. That stuff goes in everything. So we generated some images, which I guess I need to open up. Brain spinning freely here for a second. Okay, I think this is what we want. And what I want is to show this screen. Where's my OBS? What am I doing? I want to oh, that's right. We can't open it. Sorry. For some reason, OBS will not pick up the Windows default photo browser. So I have to show everything on screen, like in full screen mode, which I think is harder to read. So we're just going to open it up in GIMP, I guess. Let's make GIMP a little smaller. We'll zoom in, and then we will share the GIMP. Here we go. There we go. Boom. All right, so what we're looking at is if we get a quote, right? So backslash quote, then we're going to go to this state. And if we get anything which is not a quote, we just stay here. Cling, cling, ding, ding, ding. If we get a backslash, we come here. And if we get anything else, that's what this empty caret set is. Basically, I realized when I was doing the NFA to DFA conversion that the any character literally means just an exclusion of nothing. So I can represent the any in exactly the same way as I do any of these other items, right? So instead of the set of comma, period, or exclamation mark, this is the exclusion, right? So instead of excluded quote, this excludes nothing. So that means the any character. But we're going to replace this with a dot. I think the NFA suffers a similar issue. So here's the quote. I'll make sure this is showing up okay in OBS. Okay, so there's the quote. Then we come down here to 0 or more of the... Oh, I didn't want to do that. Good heavens. All right, we're going to open this with GIMP. It put it as a layer. I want it as an open image. There it is. All right. The NFA says we get a quote, 0 or more of the following. We can finish when we get a quote. Or we can get a backslash anything. Oh, that did work. The NFA figured it out. Just the DFA didn't. Followed by anything or anything which is not a quote. Those all go back here. Loop around and around until we get a quote. That now puzzles me. Let's look at the code for that. OBS hide again. Back to code. Log the table. Yes, blah, blah, blah. Oh. It's only the DFA that has the problem because we've limited all operations in the DFA down to basically exclusion, inclusion, and a couple of special cases. Okay. So NFA is done. We don't need to worry about it. Cool. Just DFA state.cpp. DFA export graphviz. For each transition, if it's an inclusion, we do things one way. Otherwise, we do things another way. So the transition label. Okay. Label. If it's, oh, not inclusion, exclusion. If inclusion is empty, yeah, we just make it 2-character array, fill it up. Primate Burden, welcome to the stream. Thank you for following. How are you doing today? Oh, always appreciate the follows. Oh, I forgot. Okay. That should work a little better. Yes, let me know if you have any questions or comments or anything. We're just playing around today. We're just having fun. Look at my compilation output. There's the any. Now if we go to the DFA image, Then share the DFA. On OBS. Now we see we get a quote, any number of things that are not quotes, or a backslash, and then a dot. And that dot is not in quotes, so it's not the literal period. It is the any operator. So yeah, I think that fixes that one. I think we're happy. That looks good. Cool. So let's save that work. Like I said, always try to start off with a couple of small simple tasks just to warm up while we're getting rolling. I do not have a shell open. That's amazing. Okay. Regex DFA use now output special outputs for any instead of empty exclusion. That should just make it easier for people to understand as we roll. Okay, boom, task done. Back into the journal. So we use this word printable and printable length everywhere. That was part of a refactor where we went and made the DFA NFA node outputs more consistent. So we got to go through and replace all of that, which begins in inclusion rule. Actually, it may start here. Yep. So this is one. We need inclusion rule. We have inclusion set up already. Okay, let's do this. Instead of printable length, we want C string length. And then inclusion rule, that inclusion rule, we'll place it everywhere here. Inclusion set. Inclusion set implementation. Like I said, try to start off with a nice, easy task or two in the morning when you first start up, just to get your brain fired over. And now, printable with C string. Inclusion rule, same song and dance. Beautiful. Inclusion set. Ooh, good heavens. Okay, that shows up a lot. Now, from there, NFA state, I don't think has printable. I'm pretty sure it uses printable a lot. Maybe not even that many, but you know, enough. So it's the printable len. printable C string. Okay. And then finally, DFA state. Right. That makes sense, actually. Printable C stir. Yes, yes. Yeah, basically I wanted something I could easily search that wasn't similar enough to the old method name. But now that old method name is gone, so it's okay. All right, make it again. Do a full clean, I guess. Easy peasy. Okay. Still a few lingering references. C string length. Printable C string. Pattern to NFA convert. So basically this is putting it all back together. This is a pretty easy refactor though. The one left. This code is not useful now. It may become useful later. Okay, nothing seems broken. It seems good. Someone call that refactor done. Okay, notes. Printable for any, mostly just an issue for DFA after we discarded NFA operation opcodes. The any operator was replaced with an empty exclusion. So for DFA output, simply check for empty exclusions and replace the output with something more human readable. Let's see here, DFA dot we're outputting any somewhere. Here it is. if it's an exclusion, and if it's empty. Oops, I should indent that correctly. Boom, done. All right. Yep, looks good. All right. Refactored printable to C-stir and printable length to C-stir len. Easy peasy. We already did that, so. Refactored printable to C-stir. Easy enough. Okay, 2 tasks in today, not bad. And like I said, these are warm-up tasks. 1 hour in, not even an hour in. We started late. I'm not that bad. So, in code generation. ev test if you're not empty. Right here. This is the any operator right there. Given any character, it should munch and then go to state 7. But this is not a valid check, is it? Therefore, yep, who wrote this? Who aligned to that? Shame, 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 shame. Or shame. Good heavens, what is this garbage? There, this one right here. Okay. So if we're in a particular database state, we want to emit the following transitions. If it's the first one, it's if. Otherwise, we put a else in with the if. If it's an exclusion, we say not things. Which I think is where we need to start. If transition exclusion dot is empty, true. We don't need all of this. Oh, well, we want this one. And if transition inclusion is not empty. Is that it? Mismatched parentheses somewhere. think I changed that much here. Oh. There we go. And that should do all the code generation we need. Actually run. Source builds debug. This thing. Things and stuff. So here's our text, right? We have a quote. Well, shoot. Well, the regex didn't work the way we want. Shoot, it was supposed to just work. Which makes me now wonder why not. This should all be one string. Things all the way up to here. Unexpected character at line 4. 1, 2, 3, 4 at 14. Let's look what is generated, I guess. If it's true. So what leads us into DFA state 12? If the current character is a backslash, we munch, we go to 12. Okay. So we go to 12. If true, which is really the only thing you can do, we munch that character, because whatever it is, we take it. The next state goes to 7, no matter what. A quote. Anything that's not a quote, we stay in 7. Actually, interestingly, in 7, we don't actually have to update any of these. We can save ourselves an assignment. But that's besides the point. Doesn't matter. If it's a backslash, go to 12. Unless we find a quote, then we go to rule 5. Oh no, that's the rule ID that we will accept. We munch. Our next state is 1. What is DFA? Oh, this is the forced accept state. So that's fine. See, that all looks correct. So why is it not processing the string correctly? Interesting. Prevest, doing well today, doing well. The code looks right to me. But our output, oh, bacon stromboli in the oven. That sounds good. That sounds really good. Nice. Not gonna lie, the code looks correct. But our output is not correct. The word quote things, escaped quote, stuff quote. These three should all be on the same line. But they are not. Unexpected character. So for some reason, it munched this back slash, and this quote ended the string. And then I got a token, unexpected backslash, and then one more string. So the problem was here. Oh, wait a second. The tokenizer for the string. We actually want to check for this before that. So this will match. We can do it this way. Let's go ahead and prove that this will work. Or we could, this is the problem with Regex. Like there's a million ways to build this engine to work. So basically what I was doing is just checking, are we not a backslash? Are we not a quote? Before it would check for a backslash. So we can either flip the order so it checks for backslash first, then for not quote. Or, and here's an alternative, we could put it right back in the order it was, as long as we also say not a quote and not a backslash. Either of those should be valid. Regex. So let's take this one out for now. It had to do with order of testing. That's all, I think. So not a problem with our code. There it is, things and stuff. Strings are done. The any operator completely works. We are dumping a stack trace for some reason, and that doesn't make sense to me. 1, 2, 3, 4, 1, 2, 3, 4. So let's do a full clean then. What? Why are we dying? Huh. Something that was working is not working. Not hopeful. Ugh. Man. STL vector text buffer line this. Index equals 35. Who's asking for that? It's not CPP. 1 4. This is token 1, shown in context of its line. Here's token 4, so 0, 1, 2, 3, 4. This world. Oh, now there's no 9. Things and stuff used to be 3 separate entries. Now it's not. So, token 0, 1, 2, 3, 4, 5, 6. That's all. It's not an actual bug. 6. Easy. All right. Boom. There's things and stuff in context. 5 lines, they all print out correctly, including an empty line. Oh, nice. That's actually pretty good. Any encode generation is working. Super cool. String Regex now working correctly. We could implement the string Regex a couple of ways. We might as well put them in here, right? Test.vTokenizer. With this one, and we went with could do, and I can show you this. This should work the same. We can test this first. If we don't do that, okay. Let's just try them both out, right? Building regex correctly can be a tricky business. All right, so let's go ahead and just retest this then. Compile, clean, and test, and we should get the same outputs. Oops. Yeah, anybody have any big plans for the weekend? I'm trying to think. I've got a cookout on Saturday, I guess. And there you go, same output. Different regular expression, same end result. Actually, that's a good question. Let's go to regex. What's the difference in the output? So here we get a, wow, oops. Here we get a quote. Go to 21. 21, 0, or, oh, this is the NFA. Let's just look at the DFA. Okay, if we get a quote, we go to 7. We get an exclusion of quote or backslash, we go to 7. So we can take anything that's not those 2 characters. Or we take this backslash, go to 12, take anything, go back to 7. If we had a quote, then our rule was 5, our token ID is 4, and we go to state 1 where we accept. There you go. So the other way to do this just put that one back in. Just so you can see that like there's almost always multiple ways to skin the cat. I like this reorder one. It's nice and short. Get a quote, go to 7. In 7, we only have an inclusion on backslash, or it checks for not a quote, or it checks for is a quote. That's basically it. We can go look at 7 in the VB test parser even. DFA root state 007. Right here. It has to be not a quote or a backslash. Go back to 7. Or if it's a backslash, or if it's a quote. Again, everything's muddied by how many pound defines we put in here, but we really do want to test all these combinations. Nice, okay. So we put the V tokenizer back where it was. Yes. Compile regex and test. Oh, do a full clean. The thing is, we want to test anchoring now. Yeah, that all looks good. Okay. I kept the first one for my own testing. But they both were tested and yield the same results. Okay. Any operator generating code any operator code generation is now working. String regex now fully working. Nice. Okay, we've done nothing with anchoring. So let's take a quick restroom break, and then we'll do that. Good progress so far, though. Not bad. Okay. All right, so testing anchor operators. I don't honestly know what they generate right now. Probably nothing. It needs to go right in here. This is where the anchors have to be. But they are special. My plan for the weekend is to do some packing as the move to the new house is in about 2 weeks. Oh, nice. Good. Good, good. Yep. Packing, cleaning. You want to get your cleaning deposit back. Always good. Yeah, that'll be exciting. 2 weeks. 2 weeks. Right around the end of October. Very good. Okay. I don't really actually have that much planned. So I'm trying to think. I know what the two need to look like. And I know it needs to not bunch if it hits one of these. These are not consuming ones. Emit all the transitions. I guess let's think of a pattern that we want to use or that we can test against. Test.etoke. Let's take a label, which we will keep, which will be a, I never remember which way these goes. Regex anchors. The streamline anchors. The caret is the first, and everything ends with money. So we can say caret. Let's use some Russian characters. End of line. So use Cyrillic alphabet for labels, and they have to have no leading or trailing white space. Is that what we want to do? Yeah, that's good enough. Let's just see what's outputted by the regex. Ah. Start of line. go to 7, which goes to 13, which loops around 13 until we get an end of line. Okay, let's run. I mean, so the regex looks correct, but what's being generated in those states? What was it, 7? Well, let's go to state 1 or 0. State 0. Whoa, 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 whoa. Here we are. Blah, blah, blah. Rule 0. New line, carriage return, white space. / hash 0 to 9 caret quote. Let's if current equals this. So this is the problem right here. Which means somewhere there is a $sign. Yep. Okay, so that's what it's doing. That's what it's outputting, which is wrong. What circumstances does it munch? Munch. Is that the only munch that shows up here? Two bunches. Okay, so that's good to know. So we'll need to keep a flag around for that. In fact, let's just put a flag in. So for the bool munch equals what's in the accept? Interesting. Okay. think we need to do it at runtime. I don't think we can do it at code generation time. Interesting. So let's ignore munch for now. Down here. Blah, blah, blah. Transition off. Let's just do this for an exclusion or an inclusion. It basically looks the same in this point. Else, I should have other things that pop in here now. Unsupported, unimplemented, not unsupported. Let's see here, op code generation not implemented for this operation, which is, who does the operating? Is that DFA state? Yeah. DFA state op name of transition operation. Let's just see what it puts out. Whoops. Oh. Okay, so yeah, start of line and end of line are not supported yet. Correct. Implemented. Okay, so actually this is not that bad. Else if, maybe we put this all in a switch statement. Do we want a switch statement? Switch transition off. Case. I mean, already that feels better. DFA state operation, end of line. I think we call it start of line. We'll do something when the default is we aren't supporting that yet. Oddly, most of these should never be supported. So let's just come in here. Character should not be supported. Any should not be supported. Alternate should not be supported. Interestingly, also, group should not exist anymore. We got rid of that. What am I saying? It's not supported. We want to, okay. So inclusion, exclusion, any start of line, end of line we do handle. We don't need any of these. There we go. So case, these should be invalid at this point. Just because we copied the opcode list over from NFA state does not mean that they're supported here. It should be invalid at this point because of all the transformations we do between NFA to DFA. So we should throw an error if we do that. Okay, so we're going to go case DFA state operation colon break error VB project dot init transitions opcode should never appear here, which is this thing. Default and break. Okay. Now let's see what we get. Oh, let's see here. To implement operation name for the same thing. So we should see these two lines print out and nothing else. None of these two should show up at all in theory. We put the right number of parentheses in, that is. Group? Yeah, I thought I took group out. Oh, need more gum. Okay, so to implement, yes. Nothing else as expected. All right. These are similar, but not the same. All right, I need new gum. So while I think about this, so here's part of the problem. If we match on a start of line or end of line character, we do not want to munch. Everything else wants to munch. So, and that munch happens in two different places. It can happen on an accept, or it can happen on just moving to the next state. Since it can happen inside of an accept, that's the problem. I think for now, what the tokenizer needs is a flag. So we're going to code snippets assets for the tokenizer. In private, here. Do the munch. I think this only matters if we're not in go-to, right? To do only for non-go-to dispatches, question mark. We only need this flag declared in the class level. We're not doing go-tos. We need this state to maintain across function calls. Tokenizer get munch can be true. I have not been consistent about these classes, have I? Not really. Okay. VV project. Do munch equals false. Meanwhile, before we emit transitions, do munch equals true. If do munch do munch. Oh gosh, let's see what that even looks like. Oops. I'll do a full clean, right? Doesn't take long in this program. Okay, and it fails in reorder. Oh, for Pete's sake. Okay, fine. Okay, so this is only in our generated code. So I'm either missing a parentheses. Yeah, else if blah blah blah. Which is, I think, wrong. Okay, this is just the test condition. So all we need to check is m_current oh shoot. You know what? Let's do it this way. Is start of line and is end of line. We'll wrap up the logic inside the current character itself. It'll say we don't know what that method is. We'll go implement it. It won't be a little hard, but it's I don't even like that name. At start of line, or is at? Is that end of line? Okay. Assets, code snippets, character reference. We're going to start with the UTF-8 because it's the most complicated. Is valid. String value advance to end. Is there not some booleans here that I guess next to is valid? Oh, it is white space. That's the kind of thing we can put in here. Okay. Is at start of line. Is at end of line. Okay. So we're at the start of line. If we're at the very first m_byte offset equals 0. Or if the byte after the current byte buffer contents at our byte offset plus our byte count. So if we're at an offset of 32 and our byte count is 1, so we're looking at byte 33. Next char equals, or next char let's see here. I can see several ways this might go a little weird on us. The main idea is next character equals \r, or next character equals \n. But what if it's the last character of thing? This will cause us to overrun that array. So I have to ask that question as well. All right, so if m_byte offset is less than m_buffer I can't remember what that's called. Code snippets, text buffer implementation. And what we care about is size. And so if we're at byte 0 and the buffer is byte 0, it's size 0, so we have an empty buffer, it will return false. We would not be considered to be at the start of the line in an empty file because there isn't a line. I think that seems reasonable. Next character should only be computed if this is true. So is that as simple as I can make it for UTF-8? Now, if we move forward and the character is anything else, doesn't matter. I think that's it. So at end of line, byte offset we're at the end of the line, if we're at the end of the buffer, which, if it's an empty buffer, does it matter? Okay, so what if we have a pattern like this? I'm just trying to understand the problem. If we have a pattern like this, where we start of line A through Z $, right? So we get a single lowercase letter. This all works great. Are we actually using this? Oh, for the, okay, end of line trimming. Yeah. I think this is all inside the private section though. This needs to be moved out. No, who's my friend? Text buffer and string reference. Okay, so that makes sense. At end of line. If my byte offset is greater than or equal to buffer size, or Because what I'm thinking is, if we have this pattern, that's fine, whatever. But what if we have this pattern where it's 0 or more, right? Then we could have an empty string match and return an empty token, which is probably not ideal, but do I want that? Do I want an empty token? I mean, that's a stupid regex, but do I want to break on it in weird, unpredictable ways? Or is it better to return an empty token, which the user can then debug? As opposed to them saying, I never got this token. But they do expect an empty token. I don't know. How do I feel about that? What do you people think of empty tokens? I don't see any reason for an empty token. Otherwise, if we want to support the empty token, don't support empty token. If we do want to support the empty token, we'd have to look something like this. If byte offset is less than underscore buffer size, then basically return this. Otherwise, return just this thing. This one will handle the empty buffers, the empty token just fine, regardless of what I do, I think. So I would have to check if byte offset is 0 for us to reject the empty token on the end of line check. I don't like the branching though. Can we restructure this so that there's no branching? This could potentially happen a lot in a text, depending on token branchless. Return. We're at the start, or this buffer size is less than, and these things. How does that make me feel? Are we at byte 0? We're done. It short circuits the or. This code never runs. If we're not at byte 0, it checks the buffer size. And if we're at the end of the buffer, we're not at 0, it defaults. Otherwise, it checks the next character. I think that's correct. I think we'll stay with that for now. Okay, either. our byte offset is greater than or equal to our buffer size. Ooh, I think we want equal. I don't think we want greater than. I think there should. If it equals our buffer size, we can point backwards one. But if we're greater than that, looking back one byte does not help. We can still do this. It's fine. Greater than or equal to m or m underscore buffer contents at underscore buffer. Contents. We're just going to shrink this down a bit. Buffer size or buffer at m underscore buffer size -1 equal to a new line character or the previous character equals this. Okay, is that easy enough to understand? If we are passed into the buffer, it's true and we just short circuit. Otherwise, look at the previous character for R or N. I think that's reasonably easy to understand. Let's see if that compiles. Oh, curious. It wants parentheses, which I put, so why the, oh. I guess that makes sense. What's another set of parentheses here? Okay, what else is it not like? Oh, not info, jeez. Okay. All right. It is declared privately, so we did forget to move that. Okay. That's fine if we move this up to, I guess, here. We can, oops. Yeah, that's right. We can clear these const. There we go. Yeah, if you're going to do line-based parsing, it's nice to check for the end of string, or to end of line, or start of line. without having to consume characters. Is at end of line. Hey, there it is. If we're at the end of line, this one. So, I mean, this part's wrong, but that's fine. Is at start of line. And again, that's wrong. Okay, so I think we're doing good. This won't work yet. Because that is just wrong. This. So this needs to be depending on where we are in this loop. Munch equals true. On entering any state, okay, Tokenizer initializes with do munch as true. We don't know how that works out. At the start of every state, we do munch equals true. We don't have to do that. The only place we really have to do that is right before dispatch, right here. Not here. Woof. Let's see. Next state equals this. Right here. This is where it needs to go. Regardless of how we get to the next state, we should set munch. Munch equals true. We're gonna have to do it there. That makes me happier. Do munch. Starts off as true, sure. This thing for every time through the loop, start with munch equals true. If we're at the start of the line, do munch equals false. Oh, unexpected character. This one needs to munch no matter what, because it's unexpected character. Okay, so let's go fix that. Yep, same. Oh no. At end of line, we do not munch, whether we accept or not. Okay. If we do accept actions, oops. Initialize, pop up every processing loop, only for non-go-to dispatches. Probably. Do munch equals false. Oh, I thought I changed that. Oh, we didn't reload, did we? Only got 2 of those. So that brings us the question of accept actions. No. Accept end of chunk 6. Which one was code check 6? Right, tokenizer. Okay, end of 6. Right, accept function cases. There we go. This is the one we're looking for. This thing never munches. Oh, interesting. Yeah, any munching has already been done before we ever even get to this thing. We never munch in accept. Starting token? I don't think it munches. Yeah. Okay, we don't need to pass around this stupid variable. Oh, thank heavens. Oh, come on. Too much. There we go. Now this one I need. This one I need. This one I need. I don't need this. 1, 2, 3, 4. That's it. That's all the munching we need. Okay. Phew. I think that's better. So we need a test case for this. So test.cpp. Need to capture a Russian word. That begins and ends a line. And we need probably 2 different versions of it. One here. One here, one here. All right, I need some Russian words. Let's see here. Google translate.google.com. Egg to Russian. There it is. Yitsu. Oh, black. There we go. Yitsu. We're going to do eggs, or just egg. Bread. Oops. Bread. Clear. Here. And we want this one, which is, let's see here, we've got bread, candy, confetti, which I'm probably pronouncing wrong, but you know what? Does it do capitalization for me? Nope. Oh, it does. So we can make this one be a partially capitalized word, just to prove we can. Yitsu. Might as well do it for bread while we're doing it for everything else, right? Pretty good. Let's see here. Elephant. Slon. We want this Russian word to not be one of these special labels, so we'll put it in there. This changes the order of all sorts of things, but it's fine. Compile. See if anchoring is done. We should get 3 Russian words that are marked as, I don't even remember what we called it. Test.vtoke labels. Oh, unexpected characters. All right, so things are not working as expected. Line 1, character 4 is the new line character. Well, shoot. And then it just, yeah, dies. Slon. No, this is Slon. Yitsu. Yitsu. Egg. Unexpected character. New line at line 1, character 4. Okay, I think I know what's going on. I knew we'd run into this eventually. Do I want to fight this now? Actually. Okay, so this is good. This is good. I've been waiting for this one to come and bite me for a while, and we've gotten away without fixing it. So let's take a look. Basically, there are 3 or 4 things I want to do that I've been like keeping in my back pocket, waiting for the right moment. So YouTube, if we go to our test.vtoke page, label comes before token ID. So the first thing it should do is ask if we're at the start. Well, let's just remove this for now. Let's remove the Cyrillic token ID. Huh. Text. Huh. Okay, maybe this is not what I think it is then. Clean, rebuild the whole test. VB test parser, reload it, is at. Is at end of line. Next state is one which is an automatic accept. So it's not munching. So is at end of line, is that what's crashing me? Or don't think that should be crashing me. Because byte offset should be smaller than buff size by the time we use that buffer object. Let's go look at the DFA. Start of line, go to 7. 7. We get a Russian character, go to 12. We're at 12. As long as we keep getting Russian letters or underscores, we keep going to 12. Or we hit the end of the line, where we go to 1, which is an auto accept. So regex looks fine. Unexpected character new line. Okay, here's the thing we want to do then. Unexpected character at do I have the state? I do. DFA state thing. Which was called state. Give me state, it's just state ID. Build a test case with it. If it's 12 and it says, I don't know how to do this new line character, I'm going to be upset. Or at least mildly perturbed. Boom. Okay, so we don't care about all the rest of this because it's already jumped the shark. But this point, right here, DFA state 12, unexpected character new line. Is at end. So it's not matching, is at end of line. Which I suppose means something is wrong here. Oh. Oh, no. Definitely found start of line, so this is valid. This is not working. ChrRef is at end of line for byte modulus d of modulus d, which would be m underscore byte offset buffer 0.2 size. That'll at least tell me what we're looking at here. Okay. So I've had a couple of questions now about Why don't you just use raw string term string literals? And I guess the reason, one of the reasons is because of what we just did with VB project here. I want this thing to be formatted. I didn't want these things to be formatted, so I just escape everything. If I escape everything properly, then I can always insert what I want when I want. Whereas if I have to go change string types and keep track of which ones are raw, which ones aren't. I don't know. I don't know if that's a good enough explanation, or probably I'm just too lazy. Okay, up to the first one. Byte 8 of 99. There are 99 characters here? I suppose. DFA state 12, unexpected character, new line. Um, 1, 2, 3, 4, 5, 6, 7, 8, which means the current character we're looking at, not the next character. Is that my problem? Oh, not buff size. Oh, good heavens. So we're reusing it. Okay. All right, let's make this better. Is it greater than or equal to or at the bind outset? I'll bet that just fixes it up. Dandy. So we need to look at the character we're looking at, but not also consume it. So I think that's right. I don't know why we're looking from the tail end of the file. Boom. Okay, so we have a label, Yitsu. Label, just the first character of Julian. And I don't see the other one. Interesting. Unexpected characters. Our text. Yitsu hello omega capital Omega X slon. So did we get slon? Oh. Slon. I wonder if we can put that line back in. I'm just curious now. That's not. Test or veto. Let's put that back in. Put both patterns in. Maybe it'll fix slon for me. That would be nice. Processing begin and end. It didn't get broken. So our tokens are Yitsu. Slon is a token ID because it wasn't at the exact new line. And token Lieb and token Confieti. I actually think anchoring is just about done then. A couple more tests to run on this. What if we do that? It's not nice. I'm a little bit pathological trying to run this test. I bet it fails. Because now slum, elephant, Oh, it did work with Sloan. Oh, is this my latest run? Really? Sloan. Even though it doesn't have a... Oh, that's beautiful. Really? Even though Sloan matches that StartOfLine character, it does figure it out. Good. Oh, no, it doesn't. These two are not labeled. These two are not labels. When this one went token ID, these... Oh, dear. That's not a failure mode I expected. Oh, these are not token IDs. Why not? Label. Sloan. Yeah, these are not labels. Why are those not labels? Well, they never have been. Oops. Okay, so it never quite worked. Right. So close. So in other words, byte 0 is the only thing that's actually launching us. If we have a pre-n, it's not catching it. Therefore, this is marked as a token and not as a label. Okay. If our byte offset is 0, or oh, we have to go back one. This is basically the opposite of the problem we had over here, where we were looking at the next character. We can't look at the next character, really look at the current character, because we already consumed the \r or \n previously. So we have to look back one. And this one, instead of looking at the next one, looks at the current one. Yeah, so this is... I think that should fix it. Okay. Label, Yitsu. Sloan token. Clear. Confiete. Um... Okay. I know what this is about. What's wrong here? These not picking up still. Arg. Still not. Oh. I know why. If we add the byte offset, we're looking at the next one. We need to look back 1 byte from where we're currently pointing at. And we don't care if this is a valid continuation byte or whatever from UTF-8. We just literally care if the previous byte is that. Okay. Streamer brain. I could think straight and talk at the same time. It would become obvious to me that adding the offset and then subtracting a byte would not work. Boom. Yitzo, Slon, Lieb. One, two, three, four, five. So my backup characters is not working. And it's not grabbing the last one. Oh, interesting. So there's a problem in our main processing loop where it will not match anything at the end of the document if that's an end of so I have to break out our loop differently. I have some ideas. So let's test this real quick. I'll pathologically do that. Just see what it does. It may tell me it's an unexpected space character and then fail a bunch after Sloan. It did. Right after Sloan, it went off the rails. Okay. What we could do, I'm just curious now. There we go. So we could say this or this. That might fix the issue of the other thing. Just for funsies. Okay. Yitzo, hello, omega, comma, slum is a token ID. Label is not. Okay. So that fixes it. All right. Things to think about. How does things and stuff pick up the X from here? Let's go look at the backup pattern. Well, this is working. So we're going to copy that to character reference ASCII. There we go, character offset. And that's basically it. And then that's basically that. And then for our Latin 1 encoding. Where's my character offset? There it is. Oh, it's in. That makes sense. Okay, so that should be fine. Back 1. When we mark a line, when we mark a line, so that's in text buffer. Define line. So our end character right now is the X. If C is not white space, and C is invalid reason is not end of buffer, so for the end of the buffer, fine. If what we have is white space, fine. But if not, we need to back up at least one, right? We should never need to back up more than one here. Because we will not include this character in our line. We trim so we can include the, yeah. Let's try that. I think anchoring is very nearly done. Okay, no errors there. Yitsu, hello, Omega, Comet, X, Slon, World, Bang, Things and Stuff, String, Period, Lieb. These lines look better. Thank you. We're not picking up this one as a token. And I'm not sure why. We picked it up as a line. Oh, end of file. Oh. Wait a second. Confetti. Candy. Okay, so here's what's happening. While character is not at end of buffer, work on the next DFA state. But if you look at this pattern here, test.vcoke, it says a label must end in an end of line character, which includes the end of the buffer. So that one ends up in a state is at end, where is at end will never be called if we hit the end of the buffer. This code is going to be so small when we're done. All these different code paths will be deleted because we'll have tested our performance across all of them. So what's happening is it's inside this while loop. Not that one. Not that one. While the iterator is not at the end, or while the iterator is not at the end, really. Okay. So how do I determine when I'm done or not done? The very last token in the stream requires an end of stream token, an end of line token character at the end. Not a character, anchor. It will never be tested because of this. So how do I know when to exit? I need a new exit condition. These whiles basically need to be true. Okay, terrible ideas. If the iterator's at the end, we ask what our next state is. When we accept, we go back to the root state, which is the start state, which is 0. It's always 0. So we have to both be while and. Means every single state has to check for end of buffer itself. Ooh, I don't like that either. Oh, lads, what's going on here? Because now at the end of all this is one final accept. Root rule none. Oh. So that's why we got the empty line. It failed the character. Oh, did it fail the character? What did it do? Current rule ID might have been none, actually. Anchoring makes things more complicated. I think it's a useful tool in the toolbox, but it's messing up my loop. Before we could just check for end of buffer and exit. But no more. So what are the conditions to exit the loop? We only exit the loop at the end. And only if the state is not equal to the root, the 0 state. stuck. It never gets stuck in a state where it's never the end and it's never accepting and it's never erroring. Not sure. Basically, is there a case where in root 0 you could be checking for end of buffer? That doesn't make any sense, does it? In state 0? No regular expression should ever start with end of line check. Nope, that's not true. No, that is true. So we can say well, the iterators are at the end, or oh, so let's see here. If the iterator is at the end, and oh, let's comment this because we have 3 cases depending on how we dispatch. Well, oof. Oh, man, this gets complicated. Iterator equals end and next state equals that. I think that's the general idea. Unfortunately, for just function pointer, this is actually really bad. In fact, this may invalidate the whole function pointer direct in its entirety. Unless I pre-bind all of them into this function array. I can do that. We're already doing it somewhere else. And it doesn't matter if it's a bind or not. check if it's this. So what's that called? VB project. There's like a dot up here. It's on switch. State ID, rule ID. This is the DFA function array for bind and lambda. This one right here. These state functions. Therefore, function array, if defined, or if this is defined, DFA dispatch function pointer. Either way, we have to output this. Lambda okay. We don't need this. We don't need this. Or this. Or this. Because now we aren't binding it at this time. We're doing it at this time. Which would be safer if it did this. Which means this enumeration has to be available if we do function pointer as well. State ID function array or find DFA dispatch function pointer. Function pointer. Is that right? Because now Tokenizer, while and lambda don't matter anymore here. Let's get commented out. So while underscore DFA state functions have the feel goods about that just yet. I want to run it, see what happens. There are times when you make a change where it's like, oh yeah, this will work. And other than fiddling here and there, it's fine. But in this case, oh, it actually worked. It did pick up the last one finally, correctly. And it worked. Good. So if we go to our make file, right now we're running it with the dispatch switch. We made enough changes that I think we need to do this. We're going to run it with a function pointer. We actually significantly changed how the function pointer thing worked. Now we have the ID enumeration and an array that we pre-bind. Which it did not like. Oh, state ID, state ID. Okay. That's easy to fix. This one, what's wrong with this line? Oh, yep, okay. Okay, so VV project. Let's go to Tokenizer. This goes away. So yeah, now we're no longer binding or lambda-ing it every time we go around. That should help. 3:30, it's almost snack time. Snack time, I like snack time. You gotta get up from the computer once in a while and stand up, right? That is correct. Tokenizer. Static cast int. I just want to compile. We'll run it when I get back from snack run. Uh-oh. What is this? While... Oh. Okay, fine. Static cast, then array subscript, then close parentheses. Okay. All right. I'm going on a snack run. What I'm thinking right now is that's going to leave me in a sad state. So I'm going to think about it while I go do a snack run. We'll be right back real soon. been thinking. 1. I'll chew gum so long. 2. Can't compare lambdas. I know why, but it still makes me sad. Because it's really just a function pointer, right? Except that they've wrapped it all up inside of all kinds of object-oriented garbage. So you can't just compare. Like, I have an array of these lambdas, right? And if I say this lambda equals that lambda, it doesn't take a pointer and say, yeah, show the pointers and then compare the pointers. It literally is comparing the objects. So there's no equivalency testing. So the only way to get this to work is here where it says next state, if we're doing a function pointer, oh, this actually simplifies code though. Okay, so in the function pointer thing, we no longer need this bind versus lambda because we're just going to use that array of pointers. But the next state now equals m underscore dfa state functions at static cast this thing. Static cast array dereference thing. Okay, so there's one piece of it. Next state equals, and this is, oh, lazy. Yeah, we're not lazy. We need to be outside of lazy. Although this all goes away. Okay, this is batch processing. State equals things. Oh, we should do that. Okay. Dispatch. All right. The bind goes away and lambda. And what we get is this one. Which is identical to just looking it up from an array, therefore invalidating the whole thing because we can't compare lambdas. So we're literally looking it up. All right. Deep in thought. We might need to rewind some of this. This is why people don't actually write code the way I'm doing it, where you write every possible combination of things. It gets very confusing, but but it's we're doing function pointer. We need not this array, but we do need a different next state thing. I need something for comparison purposes, which makes me a little bit sad. Okay. Um, Start state method. Function pointer bind. And lambda. We're going back a few steps. I think we'll be okay. With something like this. std bind tokenizer this thing with this. This one is a lambda. Um, I want lazy. Oh. Where's the end of lazy? I want to stop looking at lazy until I'm ready to address it properly. Okay, it's a function part of this one here. And the STD version. If def function pointer lambda function pointer bind Hey, G Finelli, doing well, doing well. We're doing compilers today. We're building perhaps one of the worst tokenizer generators ever, because everywhere I have a choice to make, I implement it both ways inside of defines. Because I really want to get this thing working, and then performance check every combination of performance options. I think it will be instructive in a way that reasoning about the system is not. So this could be fun. That's the theory anyways. Find then lambda, huh? I don't mind switching them, that's fine. So thinking something like that. So when we dispatch on a function pointer, that's much simpler. I like that. How are things in Brazil? That's fine. We still need that. That's fine. We still need that. Yep. Okay. Next state equals. So this is where this one comes back. Um, I don't remember how this works. Test pressure. BFA root state. Oh, no, this worked fine. It's only the start state, so it's fine. Yes. function pointer. It needs those methods. That's fun. Is that it? Dispatch on the function pointer. Fine here, maybe a lot of rain in these days. Yeah, we got cold. When I was doing a parser, the tokenizer was really simple, and the parser itself was just a recursive descent one. Yep, that's the way most projects should probably do it. 100%, way more efficient than what we're doing. A tokenizer is just a for loop, and based on what character you get, you go to a different processing function. It's not rocket science. What we're doing here is way overkill. I just like working with the DFAs, NFAs. I want to do some fairly significant performance testing of different methods. Like, this is just for me to have fun. That's why we only do it Fridays. This isn't something I'm going to like deliver. Maybe someday we'll make it public, but like, this is just a Friday project. So we get to do it in the worst way possible, and it's going to be great. Glorious. Yeah, recursive descent's pretty good. I've heard people talk about Pratt parsers, which is basically, as far as I can tell, a recursive ascent. It's basically where you modify your operator precedence order on your way down the tree, not on your way back up the tree. That's the short explanation, but yeah. And I've written both. I've written hand jam tokenizers. I've written Lex based or Flex based tokenizers. I've used Bison, which is like Yak but open source. I've also written my own recursive descent parsers, line-based parsers. I've written my own LALR parser generators. Yeah. The only thing to do is to just play around with it, right? And we're spending a lot more on this project on the tokenizer than I ever have. It's just for science. For science. Which is one of the reasons it's so darn fun, I think. Can I just undo this region? Does it remember enough to give you this back? It does. Next state ID equals state ID colon. I don't remember what this feels like. State ID, DFA root state, this thing. There we are. Because we need that state ID for comparison. All right, what else do we do? Function pointer. Dispatch function pointer. That's it. All right, maybe we can try this now. Oh, yeah, I think Pratt is just a recursive descent with precedence as power binding. So with a recursive descent, what happens is you go down the tree, and after you've parsed both the left and the right side, so you have to go basically all the way to the leaves. As you collapse back up the stack, that's when it rebalances. So it says, on the left I have this, on the right I have this. Now, if this has a higher precedence than me, we do a left rotate or a right rotate. That kind of thing. In a recursive ascent, it's as you're working your way down the tree, you say, take what's on the left, take what's on the right. We're going to build ourselves, but we'll check the operator on either side, and we'll actually build the tree in the right order in the first place before we completely recurse down. So basically it's checking as it's going down instead of on its return back up the tree. So nothing is parsed all the way down to the leaves when you do your operator precedence reordering. It gets barely enough information to say higher or lower and moves on. I don't know which is more efficient. That's not a parser we're going to write in this series. Just due to time. Like, I'd love to build one of every kind. But who has time for that? I don't have time for that. I'm only working on this once a week, and nobody's paying me to do this, so it's going to take us a long time. Is that compilation actually finished? Mostly. Multi-line comment. Probably safer not to. All right, fine. We'll put it back in. Actually, what we should do is this. That is cleaner, I think. Do the same thing here. Yeah, exactly. So when you did the descent loop, when the BNF would be infinite loop to get all precedences correct. Yep. Basically precedences from back to top. Yeah, exactly. Just changes the order you do things in. It's not a big difference. I don't like those warnings. All right, fine. Oh. Ha ha ha. That's why. I also like parser combinators. Yep. Using like a more functional language like a Lisp or a Haskell or something. Which, as I understand it, basically end up being recursive descent typically, but the way it's expressed is a little bit more natural. If I remember. Okay, yeah. It ends up being very much the same. Okay, so we just did dispatch on function pointer successfully, and it did pick up the last token correctly. And I did not change that test, did I? Yeah, I did not. Good. Perfect. Oh, okay, so that was terrible. I did not plan on doing that. But this one should be simple. So we're testing dispatching our DFA states using 3 different methods. We'll use 4 eventually. For now, we're dispatching on a switch statement. So basically, when we say, here's your next statement, your next function, next DFA state, it is just an identifier that it looks up in a switch statement. The one we just did was function pointer. So when we say, hey, here's your next state, it literally just hands a function pointer to the next state and just calls it. The third method we're trying right now is we have an array of function pointers, and the next state is just an identifier which looks up in that array. And I have my suspicions about which one's the fastest and which one's the slowest, but we're not going to talk about that until we're ready to measure. Then we'll do final predictions and see how everybody does. Okay, all of them are here. Label, token IDs. So Inkring's still working with all the new stuff. Perfect. Great. Oh. So Inkring works. And we just retested using all the different dispatch methods. So we can go back to switch case. This is basically my default setup. We're binding all of our function pointers. Instead of using a lambdas, we're using dispatch switch. Oh, interesting. Okay, we should probably do one more test before we commit this. The function pointer can be bound using either lambda or a bind. We just tested bind with function pointer dispatch. We should also test it with lambda. Oh, come on. File, journal. My journal is not saved. Interesting. By the way, I finally just got a possible development roadmap of things I need to do to make my game. If you can take a look someday to add to it if you think I missed something useful there. Nice. Sounds good. As far as roadmaps, let's see here. I have too many tabs open. Did you send me a... Yeah, let's see here. Is that... You can send it to me on the Discord. You can send it to me... I may have a tab open with a GitHub if you've pointed me at that. I have so many tabs open now. I've been trying to get this darn business registered. I went online last night, like I got my kids in bed, went online last night, go to the federal government and say, hey, give me a tax identification number. Their web page said, this page is down outside of hours of operation. It's like, what? Why is a web page down for hours of operation? They have like a time, they're like, this web page will work from this time to that time. Blows my mind. Yeah, actually, if the fact that you have a development roadmap for your game puts you ahead of me. I've just been winging it. Now, that being said, I have worked on larger projects, so it was more clearly defined. So it's not like I don't know what I'm looking for, but okay, so that also worked. Great, everything's perfect. Now we put it back to our default running method. Go back to dispatching on the switch statement. And with the bind method for function pointers. Oops. Function pointer lambda. There we go. All right. Anchoring now works. Had to add some functionality to the character ref. Oh. Question, did I copy those changes? There are some changes. I'm not sure. I copied all the places they need to be. I made a roadmap because I have no clue where to start, so a roadmap is a good way to not get lost. Yep. If this wasn't my first game in itself like this, I would just do a roadmap, just a list of features. Yeah. Nope, a roadmap's good. Like you said, it helps you get the picture. Writing anything down is always better than just letting it live in your head. And then 2, don't become too tied to your roadmap. If something needs to change, just change it. Like, it's your roadmap, do it how you like. A lot of times I've seen it, like, especially from like a business perspective, I see people like, let's make a plan. And then they write a whole bunch of crap down that nobody's ever done before in the company. They don't know what they're doing. And then you spend the rest of the project and all of these uppers are like, well, why isn't this thing done yet? And why is that thing, why are you working on that thing? And like, it needs to be flexible. You discover dependencies, you discover requirements as you build it the first time. By the time you built it 2 or 3 times, yeah, sure, you know the requirements, but just be flexible. Yeah, send it along to me somewhere, and I'll take a look at it. I like looking at people's projects. What did I change? Trim trailing back one. Okay. So that was not my problem. ChrRef, UTF-8. The other thing we did was this. Okay, now I remember. Character reference, Latin 1. Character offset -1. At character offset. Okay, so I think this is okay. These all look similar. Good. Okay. So within our journal, this is okay. Had to add some functionality to character reference to ref implementations to check for start of line and end of line. It's also changed the way the loop terminates because we can't just terminate on a end of buffer and end of line check will not be run in that condition, in that case. For the last token, would not be run in that case. What else needs to be said about this? To support the additional loop termination checking. Dispatching on a function pointer needed a way to compare the next state. So it also has state ID enumeration. There. I think that's all the information we need there. Happened to me before. Sent on Discord. Cool. Nice. I will take a name. Take a look. I find with a project, one of the hardest things is naming the project. So, and I'm not even going to look at your roadmap. I'll bet that the first thing on it is not name the project. So what I would suggest is you find a pattern. For example, you could use like names of locations in the Lord of the Rings, or maybe you do like the names of the planets in our solar system, or names of characters in, The Princess Bride or something. And what you do is you name your project according to that, but that is not your product name. You separate the name of the project from the name you're going to deliver, because you will change your name 5 or 6 times trying to pick a name to call your game. Even if you think you have a genius one now, like, you'll find a better one later. And even if not, like, separating the project name from the deliverable name is a good idea. So I have like a text document with like 4 different naming schemes, and after my next project will be named out in one of those lists. So that way you can create a project. Everything is referred to internally as project whatever. And then the actual executable you build, the game name itself, can be chosen whenever. Yes. So before I even look at your document, So I think that's good journaling. Git status, git add everything, commit. Anchoring works, had to rework loop exit logic, and that's a fallout. Also dispatch, function pointer dispatch. But it's working, so that's good. Phew. Actually, that's not bad. We're 4-ish hours in, and we're almost done with the initial task list. Okay, looking good. Yeah, I didn't even think of a name. That's why I did no name. Maybe I might just I did see that, I guess. I did see that your repo is no name. Might use a project name like this. Sounds useful indeed if you have more than one at a time. Yeah, as I've seen it over and over again, somebody will start a project, and this is professional as well as personal projects. They'll be like, oh, we'll call it such and such, and then they create a whole project directory. They write up their design documents, and then they're like, oh, I don't like that name anymore. The game has changed, or the project is a little bit different than what we initially started with. And then they got to go rename the repo. They got to go through all the documents and change all the names. It's like, no, no, no. Pick a project name. Does not matter. That's not your deliverable. Then you can change the deliverable name anywhere, at the end once you've settled on one. But yeah, like Greek gods are good. There's a ton of those. Yeah, any kind of just pick a pattern. Doesn't matter. Anything like special, favorite characters from whatever book or series or movie you like. All good. So I'm looking at escaped characters, am I? If I go to pattern to NFA converter, escape. Are we in escape? \n \s t t close bracket d ns t square bracket d, or that special one, because those are inside of a square braces. Here, are we in an escape? New line, blah, 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 tab, digit, white space, dot. Dot does need a backslash. Otherwise, okay. So we get that character. We take the value, and we say these characters all have to be escaped. If you want the literal. But it will do the right thing anyways. It's a warning. It's not needed, but we can press on as though you hadn't escaped a weird character. Okay. So far I'm happy with that. So all we really have to do is test all these characters in our test.vtoke junk. We will keep this junk. And it will be all of these things. Ooh. And each of these needs to be backslash with pipe backslash. Except for that one. Shoot. Backslash, backslash. Oh goodness. Okay, this is going to be hard to read. Brace, or backslash, or vertical pipe, or anchor, or anchor. What is in my test string? So we have a comma and a period. So in this case, this period is useless. We should just pick another character. %. Perfect. Okay, let's just try it out. So we're just testing to make sure the escape characters work properly. Yeah. Firstly, this shouldn't change anything at all here. Things and stuff. There is no dot. Where did this dot go? Because there is, oh, whoa, whoa. Because there is a dot in our test string here after stuff. Things and stuff. But then there's no dot. Interesting. Let's look at the DFA table. What? Oh. This.c, there we are. Compile regex. We're in the wrong directory. Okay. Square bracket, paren, plus star, quote, backslash, brace, backslash. Oh, we've got 2 backslashes here. Oh, and they both go to the same place. So we can actually delete the duplicates. No. Not sure why that's in there twice. And then curly brace, another backslash. Very odd. Pipe. Okay. Added a placeholder name. Lol. Nice. Okay. All right. I like it. Development roadmap. I will definitely take a look. I will probably take notes of what I like seeing in there, what I don't like seeing there, in case I ever get around to writing one. So all these things go to state 1, which is an accept. Oh. Yeah, that basically works. So let's take a look at the DFA for this. in graphical form. Just a minute. It takes me a second to dig it out every time. DFA, open with GIMP. We'll share that as soon as it's up. Nice. Okay. Share the thing. GIMP. All right. So there it is. Square brace. Yeah, so it is escaping correctly. I'm not sure why it is escaping this backslash twice. Did it warn me like, hey, you don't need to escape an escape? Nope. Okay. A little odd, but it is working. Except I don't see hat. Where's the carrot? Did the carrot go all the way around the outside? Pipe, carrot. Uh-oh. I probably know what happened there. Backslash, pipe. Backslash, pipe. Oh, pipe. There we go. I think that will give me what I want. Maybe. Oops, I guess I didn't hide GIMP. So what I did was I put two pipes in a row. One is the escaped pipe, and then the other is the alternate pipe with the carrot. All right, and we reload the DFA real quick. So as far as the compilation goes, there's the carrot. So that's better. I'm just not sure why there's two backslashes. We'll have to take a look at that real quick. It doesn't affect anything. It's just going to generate a little bit of extra code that doesn't need to be there. So there's the carrot, which I can show if I remember to turn it on GIMP. Boom. Okay, so all these special characters have been properly escaped and display nicely, but we do have two backslashes. Like there should only be one of these entries. There's two of them. So we need to figure that one out. And we can see it here as well in the Emacs. So this backslash. I'm glad we're testing this. In escape, this one. NFA new state UTF-8 character. Huh. I'm not sure why it's adding that second escaped backslash. This one is inside of a square brace. We're not doing anything inside of a square brace. And there are far fewer of those than here. Up here. Here. What about backslash backslash would cause it to move? Again, it's not that important. Did I type it in wrong in test.vtoke? It only shows up once. But it's outputted twice. In escape, here's our escape character. Then it's going to go basically to the bottom of the loop, which is here. And then character will advance. And we get the second one, which comes here. It's one of these special ones, blah, blah, blah. TDS dot. Otherwise, you just use the character, which is the backslash, which we already have, and push it back one time. Yeah, I'm not sure why this is showing up twice in the DFA. There's no warning in the compilation saying this is weird. Huh. Well, I feel like adding that to the to-do list. Bug escaped backslash has 2 entries in the DFA. We should look in the NFA. Maybe the problem is there. So there's a backslash right there. When we get to state 29, yeah, go to 30, which is anything. That's from string. This one does show up twice. Interesting. I wonder why. Why does it have 2 entries? 71 and 74. Curious. And after the braces, so backslash dot. Oh, hold on. There's no dot after the question mark. So this one, let's see here. Show the right thing here. Yep. I have no placeholder. Is it backtracking? Is what backtracking? My regular expression stuff only goes forwards. There is no backtracking. Backtracking costs. And I've never run into a regular expression I wanted to use in a language definition that I couldn't write without backtracking. So we're doing just a straight NFA, DFA compilation, and it just ends up with a straight up DFA, just forward, no backtracking. Early Lex and early Lex used a DFA similar to what we're doing now. But if you look at any modern Lex and output it, it's a backtracking algorithm. They got off of that pretty quick, but that was because regular expressions back then weren't very well supported in like I actually found a paper from 2012 that finally figured out how to do group capturing in a DFA without backtracking. So you can do greedy, you can do non-greedy capture, all sorts of things without ever needing the backtracking. Now, some patterns are easier if you enable backtracking, but I don't think I need it, and I'm not willing to take the performance hit. So this \dot is what's breaking me. Because here, nope. I think we can just delete that. I think that's it. I think that was the line that was causing me a problem. So if we go back into here, we find our \. So that's the one in the string. Here's the other one, but now we have a dot. Perfect. And this one, inclusion dot. Okay, so that was the problem. That's actually tiny. That's minuscule. That was, which means we should look at the DFA one more time. And it's just, yeah, that was actually just capturing the wrong letter. Oh, we never stopped showing this give thing. Okay. So there's the dot, there's the \. Boom, perfect, done. Oh, okay. Regex is a bit complicated with some dialects. Well, the other thing we're doing, so let's see, am I showing what I expect? Okay. We're supporting non-ASCII in our Regex. So like here is Cyrillic alphabet, and it just takes the range. It just works. And here's the Greek alphabet, and it just works. UTF-8 encoding. And it's going to be the only slowdown for using the UTF-8 is the cost of advancing that character, making sure each character is valid before we do this range check. This range check is as efficient as these range checks here because of the way we're doing it, which I think is kind of cool. And another thing we're doing is this white space capture. It also captures, let's see here, VB test parser, reload it, ampersand NBSP. When you say \s, we check for space, we check for tab, and we check for non-breaking space. So if you copy text off the internet out of your browser and paste it into your code, this will still work. The reason we're doing that is because I have seen too many times. So my last job, actually, we had these YAML files that were configuring systems, and people would be like, oh, I'm getting this weird behavior, blah, blah, blah. And I'd load it up, and I would show non-ASCII characters, and there was always non-breaking spaces that broke it every time. I'd replace them with real spaces and hand it back and say, try this. And they're like, what? I don't understand. So yes, it does range the UTF-8 representation of each character. Not the Unicode code point, so we don't even do that transformation. But we do move forward, we check the byte count, we check the continuation bytes, gather all that into a single value, then range check. So I think it's pretty cool. And now that that's all working, compile, clean, and test. Now, there's one or two things about UTF-8 that we don't support. For example, there are dead ranges, like just values in a range that are not supported. And we don't check those ranges, except the basically the Latin 1 bits. We don't check those. That is considered invalid. So yeah, here we are. We're supporting. So here's the token with a Russian word in it, Yitsu, Slon, Plieb, and Confetti. And here's a Greek letter, Omega. They just all work based on the patterns in test bcode. So there's your Cyrillic, English, Cyrillic, and your Greek. I know I've never seen it either, but the more I thought about it, the more I thought, hey, we should be able to do this. And I think I am. I think this is working pretty good. There were some complications. For example, let me see if I can dig up what's the resource? ASCII, UTF-8. There is a space in that I can point to exactly because I know when I ran into it. It happens in the Greek alphabet between the capital P and capital R, I think. No, that's not it. AFBO. Anyways, it's in the Cyrillic alphabet where there's a discontinuity in the UTF-8 itself. D0BF to D180. There it is. Lowercase p to lowercase r. So let me see if I can throw that up here. If you look at lowercase p, oh, come on, it really did that? Lowercase p and lowercase r. These are adjacent in the alphabet, but the UTF-8 codes are this, and lowercase r is this. So you don't go from BF to A0. You actually go to D180 because of the continuation byte. So these are not adjacent. As long as we verify that every character we input is correct, and then we can range check, this doesn't matter, this gap. Yeah, exactly. Yep. So yeah, I think that's pretty cool that we're supporting that. Where was I? Oh, we just tested. Yeah, so we did test the escape characters. Escaped characters now tested. They work. There was a small issue with escaped dot, but it was trivial to fix by removing the incorrect logic. and letting the default thing happen. Boom, done. Tested escape characters. Boom. Nice. That was our list for the day. I wasn't sure how long any of these would take. Let's go take a look at our to-do list. We took care of that actually. This is like a lower priority thing. VB tokenizer rule stores actions as a string. Generating output. We're not doing goTo's labels just yet. Lazy processing. Compute absolute file paths in the text buffer. Right now we're just using absolute relative paths, or whatever you pass in, really. Fixed pattern output. Okay, so once we've compiled it to an NFA, so in the NFA, NFA buffer. We pass in a pattern, it's shoved inside this buffer, and if we print out that buffer, it's pretty much junk, because what we're doing is we're taking a whole lot of little NFAs and we're joining them and then deleting the other. Right, so we're taking the contents of the other, shoving it inside this one, and then deleting that other one, which means that this pattern that you initially passed in and this buffer don't actually point to the text pattern from which the NFA was generated. Which means all you have is an NFA without the associated pattern, because we built up the pattern piece by piece and then shoved them together. So that's all that one means. I don't know if it's necessary. Maybe we have to rebuild it from things. I don't know. Okay. While I decide what to work on next, I'm going to take a quick restroom break. And then we'll pick a task. Okay. All right. So here's the thing. The end game is a go-to label-based dispatch, but it's enough different from the function-based dispatching that I don't want to tackle that yet. So we may go lazy process the token. And I have not thought through this process all the way. Every time I've built a tokenizer, I just batch slam everything into like a vector. Oh, actually, that's a good question. I don't remember what we're doing here. So, right, there we go. Oh, it's the context. Oh, our tokens is tokens. Okay, so never mind. So the point is, we want to do lazy. So what we're doing right now is there's a vector, and every time we get a token, we shove it in, over and over again, until we're done with a file. But lazy processing, all we ever need is one token, and when we fill it up, we send it out. Which I think is going to be more efficient in the end. But one can never know unless you measure. So I think that's what we're going to start tackling. I don't know how far it'll get. It's a significant enough departure from the way we're doing things now. Start token processing using lazy evaluation. So if we look at Tokenizer, we don't even know what the accept looks like. But we need to begin. So in test, okay, blah, 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 set the context. Batch processing. Lazy processing is so different. We just have to process it differently. Like I said, I want every option when we build this stuff. Actually, you know what we could do? When we build test, we have the defines. If define lazy, do batch processing. So I don't have to comment this out. We just let the compiler deal with it. Okay, lazy. We say tokenizer.begin. While tokenizer is not done, we need to do something with these tokens. So let's just do it out of context. Tokens dot push. Let's see here. Push back, yeah. Tokenizer dot next token. That's basically it. This chunk can go outside. This chunk in here. Begin. End. We'll log all the tokens we capture. Then log them in their context. That's the idea. We will test with this. You know what? We can do this easier. I mean, performance-wise, not easier, not better. Break out the tokens. End. Oh, there. That's basically the difference. Here we call beginner begin. We can do whatever we want while we're not done. Blah blah blah. Okay. So in theory, oh wait, equals context dot tokens. Put it back to batch. Oh, it is on batch. Good. Let's make sure it still works. I would like to trivially flip between the two flags as we will. What do you mean token was not declared? That's one. because it wasn't declared. Oh, that compiled. And it still runs, looks correct. These are all in context. Okay, so that's batch. It is now time to begin lazy processing. And it ain't gonna be pretty. Okay. Begin. So this happens in process. Line equals 0. Character in line equals 0. And the current character. Oh, interesting. Our iteration method already matters. Here, no, not there. Basically, this in begin. Oh, wait, no. Iterator end line start character. A lot of the setup is the same. Can I do this split window? Another process. Okay. I think a lot of this, basically everything down to the first while loop. Where's this iterator one? Get off. Right here. Go to is just going to be unbelievable. I think from here, to here. Okay, let's take a look. Begin. Next state equals something or something or something. So that's not rocket science. This go to is not correct. That actually does need to go away. If it's an iterator, we do those things. We do not start a while loop. But this is the end condition. So the is done actually looks more like this. Return. We are at the end. And we're not. And we're pointed at that. Okay. It's character advance. Oh, that already happened. So then that goes away. That goes away. And I think this line comes down here. Is done. Oh, I think we broke something somewhere else. Oh, okay, this is getting more complicated. I knew this would happen. Okay, if text iteration iterator. Okay. So if we're using a text iterator, we have to compare against this iterator thing and end. Underscore next state. I kind of rename next state to next state AD in some cases. That's if we're using function pointers. Here, I just want to do that. That's function pointer, so that's fine. Look up by ID. Which actually simplifies this back down. Define function pointer. Go to define next state ID. Which collapses this one back down as well, which is nice. Because these become identical. Okay, so much duplicated code everywhere. VB project. That's it. So we're refactoring this. Put it back to batch. Just make sure we didn't break anything. Okay, still looks good. Begin. Okay. All right, so clear tokens. So yeah. Okay, let's just try and keep things lined up. Okay, if we're dispatching on a switch or function array, next state ID is thing. We're dispatching on a function pointer. It depends whether we're doing a bind or a lambda, so that all tracks. Maybe save a couple of lines of code, but it doesn't really matter. Function pointer, dispatch function. Go to. Okay, this go to just needs to go away for now. It will only cause grief. So I agree those initializations are similar. Text iterator. Iterator begin, end, iter, start new token. Here we have to start the while loops. What's here we do not. But here, we want these two lines. Oops. Ugh, where did they go? Here's the iterator version. Character advanced. Why? I see. Those are the same. Good. And who sets M underscore current? Advanced does, and iterator does. Okay, so this line is excessive. This while loop is wrong. It basically is we're going to keep the logic the same while this thing and start state ID. That's basically the equivalency there. We're looking at the is done. It's this. These have nothing to do with go-to at this time, because go-to doesn't exist yet. Okay. That's simplified down nicely. No matter what, we end up with next state ID, no matter what. So we can pull that out from all of these. Here, start new token is always here, so we can save line there. Not that it matters too much. Let's see. Start new token. So we're not dispatching anything inside this function. Just initializing everything. Here's how we check if we're done, and then next token. Ooh, okay. This is basically where all the dispatch code goes. So it's gonna be very simple. We're gonna go through a loop. And while we're not done, and we haven't accepted, not done and it has accepted. So I'm currently thinking, let's see here, let me look at token. This could influence what I think to do here. What I have right now is you as a human cannot initialize a token, but the tokenizer is a friend, so I should have access to all of this junk directly. I don't like that this is a pointer. This one being a pointer is fine. This one makes me sad. That's fine. We don't care about that one. Okay, so we can do what I want. Just return a token. Token has an assignment operator, copy constructor. Perfect. So if we're being lazy, then we can do all of our tracking inside the token itself. These only matter for batch processing. We can track these inside the token itself. If def PFA, or let's see here. I can't remember what it's called. Something batch. Process. Batch. If we are processing lazy, we need bool underscore is accepted, or is next token ready. Hold on, there's one more question I have to ask about token. Do I have an is valid? Nope, I don't. We'll have to make one. And we'll just process things inside the token as best we can. So let's see here. Lazy. Something about a token. 3. Which is do accept actions, which is delightful. Oh, interesting. I'm just trying to see the whole problem before. So begin, just initialization. This is not rocket science per se. Are we done yet? We're not doing go-tos here. This is pretty straightforward. Next token. No way this can break. That makes me sad. Dang it. My brain's all over the place here. This is the way it always is when I start a new largish chunk to do Tokenizer tokenizer trailing bit can break on unterminated string token. I'm not gonna worry about that right now. Oh, it may also break in another way. Oh no. All right, I better test this while my ideas are going here. Shoot. Terminate right on a token that doesn't expect in a buffer. Like with this $sign thing. Okay. So back to make file. We're going back to batch. So if we make this one any old identifier, that might break it. Which I don't like that idea. It makes me sad. Because an ID does not expect a trailing end of buffer. Unexpected character. Well, shoot. That's not even the error I expected to hit, because Sloan worked. Oh. Well, Sloan did not work the way I expected. Oops, I forgot there was a space in there. I can swear we tested that, and we did not. Yep. Okay. That's fine. We'll just take this one. If you use an anchor, you can't significantly distinguish it from the stuff that comes after it in the regex, unless I build a feature I really want that does not exist in normal regex. So, okay, that works better. Begin, end, no errors. Did not fail, so that's good. All right, last thing to test: unterminated string at the end. It should blow up, which is not good. Well, no, it should return an unterminated string as a string, which is bad. That's worse than just blowing up. Yeah, stacked up. Yeah, okay, so that's not unexpected. Tokenizer still works for tokens that don't expect a trailing $. We did test that. I mean, this is actually a bug. Tokenizer crashes on unterminated token like string with no closing quote. Which means this is a bug, which we will not deal with today. Bug added to to-do. Okay, sorry, that was just got in my head while I was looking at things. We can remove that. Go back the way we were. Okay. So lazy processing. Start a new token. Well, let's see here. Which token we have? This next token ready is done. Next token is just going to spin until what? Is next token ready or turn underscore token? Is that true? Is Because what could happen is we get a token, we still have stuff until the end, but then we crank through a bunch of white space, and then it'll try to return an invalid token. So I think we need another function called void compute next token. Which when we do begin, compute next token. Let's just comment this out for a second. Next token. Yeah, underscore. The next token ready. Return underscore token. Then compute next token. And start new token. So I was trying to catch the flow here. So I initialize everything, I say go grab one, and it computes it, but does nothing with it. So when I ask, are we done? All it's really asking is, do we have a token ready? If we have a token ready, let's change the interface, why not? As token. Well, the tokenizer has a token for me. Get the next token, and part of next token is compute the next token, which may or may not flip this thing. So now is done goes away. This is check for end of loop conditions. Okay, parts of this are starting to come together, starting to make sense in my head. This is part of the exploration. largely compounded by the fact that we are building a very complex piece here. So this checks for the end. Then there's the dispatch. This is all initialization. Switch. So this is the while. So this is basically the body of this while loop. Is done goes away. DFA dispatch switch. Oh, it does some string reference copying, I'm afraid. Calls the next state. We do need this done. Where does this one go? Nope, that's not right. Okay. Lazy processing. You know what? This looks useful. This may be good in both versions. Make sure that didn't break batch processing. Uh, okay. Text generator. Well, that simplifies nicely. Okay. Make is done a macro as well. Let's not get too dragged into this. Is done. Should have a macro version. Okay. Slowly, we're cleaning up. Lazy processing. Kind of ended up in the same exact spot finally. Good. Yeah, I knew that this would be a huge task. We're not ready to finish in a single sitting. Okay, so that's fine. Blah, blah, blah. We're ignoring dispatch go to for now. This is going to be completely different. This is no longer chunk one, which is why we've commented it out. Okay, there's our dispatch. Tokenize the trailing bit. This is going to look very different. Then finally, I think or is done. I think we need to ask both those questions. Thing is ready. Oh, this doesn't need to actually do anything with the token. Is that handled elsewhere? Okay. Okay. if is done, and then we accept. New line, done. That's not too bad. Okay, so we have to figure out what chunk this is. And it will be very similar, but what we do with accept is going to be a bit different. So let's put this in. Let's see here. End of chunk. So this is technically true. This is chunk 1. Three, 4. This is where all the duplicate code happens. 5, 6, 7, 8. Okay, so do chunk 1 and 2. One thing we could do is all of these are in order. So we could, and I've resisted so far, but I'm toying with the idea. Chunk index equals chunk 1. That's to an integer. Get snippet chunk index really means get the snippet of code snippets ID of whatever the index is. Therefore, should be able to now do get snippet chunk of chunk index plus plus. We're going to walk through these in order anyways, right? So search for this. Search for that. Get snippet chunk index plus plus parentheses and F4. Okay, we'll try that. So what? All right, we made a mistake. Nope, don't want to do it that way either. Search. Place this thing with get snippet chunk index plus plus. Good gravy. Okay, fine, fine. It's gonna just fight me all the way, isn't it? Ridiculous nonsense. All right, we can try to be less picky. Search for code snippets. Get snippet of code snippets ID. All right, whatever. I keep trying, but can't seem to get it squared away. Then last piece, we are going to replace this with something that looks more macro-like. Oh, for Pete's sake. There's no way that's going to compile all the way, but I would like to get it to the part where it's generated the code file. So that's ending up in test parser. So things with replacement map. Oh, everything replacement map related got moved. Did it? Is done. That's literally it. So it's chunk. End of chunk 5. So chunk 6 means it those things in there. VV project. So 1, 2, 3, 4, 5, 6. Right with replacements. Given the replacement map. Gotta wrap it up soon, so hopefully this just compiles enough. What? One, two, three, chunk 4, 5. This should be 6. Well, it's end of chunk 6, so it's actually chunk 7. All right. Oh, it compiled. Okay, the old stuff still works because we are still just building against batch. But now you can see in VB test parser, if we're processing lazy, the accept is a mess. We're not going to worry about that just yet. Yeah. Munch should be fine. Begin, blah, 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 looks okay, blah, blah, blah. Compute the next token as part of begin. If we have a token, then we return the next token and compute next. That's not right. Okay. Okay. That's gonna work a little better. Token does a copy, etc., etc. I believe it deep copies the string reference, which is not expensive, so it's fine. Compute the next token. Okay. The last thing is, what the default token do? What's it set up as? Okay, so all we really need is like an is valid, meaning we've actually done something useful with the token. Bool m underscore is valid. I would like to ask that. The only way you can get a valid is if you construct it, which is a private thing anyways. The assignment underscore is valid equals other dot is valid. That basically is it. We can move this down here. I forgot we did this, but honestly, there's no reason not to. Okay, so now if the tokenizer, like if you ask, hey, do we have a token? If you didn't ask and then request a next token, it will return the default empty invalid token. So you can at least get an idea that you got the wrong answer. Compute the next token, start a new token. The reason you have to do this copy here before computing is because this will use the token itself. So we're getting one token here, and then we make a copy to return and immediately start computing inside the token we've already got. So we're going to allocate very few tokens inside the tokenizer. Okay, we dispatch, blah, blah, blah. Okay, so that's the meat and potatoes of this one. So let's go to makefile. Now, don't get me wrong, there's nothing done about this. I would like to know how that goes. Whew. Because accept is different, start new token is different, other is, wow, okay. That's true. So in Tokenizer, lazy, we don't clear the tokens. That's not a thing we do. We don't have a list of tokens. We only hand out one token at a time when you ask. More parentheses. Is next token ready. Token start line equals line. Let's just snag that. If def process batch. Lazy. Okay, I'm going to store token dot invalid equals false. Line index equals underscore line. Char inline. Underscore char inline, which we name very consistently, so that's nice. There is no ID, there's no text buffer, there is no string reference yet. Oops. All right, probably have to wrap it up here if the build works. And we'll pick up there next week. There. Now there's no way this runs. Boom, explodes, yeah. But I think we are here. And it'll blow up. That's fine, because we're not processing things correctly yet. Very good. Yep, explodes, but that's fine. Therefore, we shall save our work and be done. Oops. CC, there we go. Can't hit V for some reason. Started working on lazy processing. Main flow is in place. Many small things to do to plumb it through to the end. Mostly in helper functions. So let's add that to our to-do list. Keep adding to, let's see here. Lazy processing needs more work. Mostly in helper functions. There we go. Compiles. Okay. Git status, git add everything. Lazy processing started. Compiles, but doesn't run. And some good improvements along the way. That is done function, I think, declutters things quite nicely across multiple pound-defined code paths. So I think that's where we're going to quit it for today. Thanks for joining. You have a wonderful weekend, and we'll see you on Monday back into the game development. Bye-bye.